Okay, we're going to start section 9.3 in this video, and we're going to be talking about simplifying and then also adding and subtracting radical expressions. Whenever you're multiplying two radicals, you can combine that to a single radical. Well, if you have a single radical, you could split that into two radicals. You could also split it if the operation is division. Okay, now you can't split a radical if you're ever adding or subtracting numbers underneath. Okay, it's only for if you're multiplying or dividing. We'll be using these two things quite a bit here in this section. Now, when we simplify a radical, okay, we are looking for splitting the radical in, or basically organizing it into things that we know and things that would be kind of like the leftover here. So like I don't know the square root of 28 off the top of my head. That would be some infinite decimal, because it doesn't result in a whole number value, but it does break down for us. Okay, like I know 4 times 7 is 28, and I also know the square root of 4 is 2. Okay, now I can split this radical into 2 since I'm multiplying these numbers, and I know the square root of 4 is 2, like I said. The square root of 7 would be the leftover, and so 2 times the square root of 7, that would be the simplified form of the square root of 28. Okay, now other numbers multiply to be 28. Okay, we're looking for the best pair of numbers in each one of these. There will always be a best pair of numbers. And what I mean by best pair is one of the numbers should be something that you would know the square root of or the cubed root of or whatever the index is. And then the other is going to be the leftover. Okay. Now, if we look at part B, the square root of 90, well, lots of numbers multiply to be 90, right? I need the best pair. So I'm looking for two numbers that multiply to be 90, but I've got to know the square root of one of them. Well, I know that 9 times 10 is 90, and I also know the square root of 9 is 3. So 9 and 10 would be the best pair of numbers to use here, since we know the square root of 9 is 3. The square root of 10 does not break down further, so 3 times root 10, that would be the simplified form of the square root of 90. Okay, here's the square root of 72. How does that break down? Well, if we were to use 36 and 2, 36 times 2 is 72, and I could split that, okay, and I know the square root of 36 is 6. Root 2 would be the leftover on that, so 6 times the square root of 2, that would be the simplified form of the square root of 72. Now, other numbers multiply to be 72, okay, like for example, 9 times 8 is 72. Now we know that the square root of 9 is 3, okay, but there'd be a problem in that the square root of 8, the leftover here, is going to break down further. Okay, like 8 is the same as 4 times 2, and we know the square root of 4 is 2. Now I'd still get the same answer, 6 times the square root of 2, but look how much extra work I've created for myself by not selecting the best pair of numbers. In other words, the point of this here is to say, when you're selecting numbers, select them in such a way so that you don't have to simplify and then simplify again because you didn't get the best pair. Okay? I'd still get the same answer. There's no problem with that. It's just I've created more work for myself because I didn't select the best pair. Okay? And I'll also see some students just stop right here and say 3 root 8. Well, 3 root 8 is not the complete simplified form, right? So when we say simplify, like anything else that you do in math, go as far as you can, okay? Make sure that you are in complete simplified form, and that second radical does not break down further. Let's take a look at the cubed root of 72. Now, at this point, we should hopefully know our basics about square roots and cube roots. Okay, ideally we should know the square roots that lead to just the counting numbers 1 through 12. Okay, what I mean is like the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, okay? Those square roots that give us a counting number that would be either 1 through, 1, 2, 3, 4, all the way up to 12. When it comes to cubed roots, we should also know the basics for those also. The ones that would give us like the counting numbers 1 through 6 ideally would be ones that we'd want to have memorized here. Like the cubed root of 1 is 1, the cubed root of 8 is 2, okay, the cubed root of 27 is 3, the cubed root of 64 is 4, the cubed root of 125 is 5, the cubed root of 216 is 6. Like you should at least know the first 6. All right. The reason why I would say that is because those calculations seem to come up over and over and over and over again, and they're just worth knowing, okay, because of how often we see them. So, we should be familiar with like our basics when it comes to the, square roots and cubed roots at least. Okay, so I'm looking for a best pair of numbers. Again, there will always be a best pair, and because lots of things multiply to be 72. Now, I would not want to use 36 and 2. Because I don't know the cubed root of 36, that's not a whole number value, and I also don't know the cubed root of 2, that's not a whole number value. So that doesn't help me at all if I were to use 36 and 2. 36 and 2 worked great in the last problem, but that was different problem, different index. Okay, now 8 times 9 is 72, and if I split that, okay, I know the cubed root of 8 is 2. The cubed root of 9 doesn't break down further for us, so that would be the leftover, and 2 times the cubed root of 9 then would be my answer. That'd be in complete simplified form. Here's another one, part E, the cubed root of 135. Okay, now, obviously I think another point to mention here is that we should be good with our multiplication charts. Okay. A lot of what we're doing here is with multiplying and dividing numbers, okay, and we're looking for 2 numbers that multiply to be another one, or 2 that divide to be another one. We'll see that later. And there's always the best pair, right? So if we struggle with our basics with multiplication, like that's gonna be a big problem for what we're doing now. 27 times 5 would give you 135, and by the way, the fact that this is a cubed root means that automatically I need to be looking for numbers like 1, 8, 27, 64, because I know the cubed root of those numbers, right? I wouldn't be wasting my time with other numbers that I don't know the cubed root of, okay? So ideally, we should be getting 27 fairly quickly, okay? Because 8 doesn't go into 135. You can, move on to the next number that you know the cubed root of. 27 times 5 is 135, and we know the cubed root of 27, that's 3. The cubed root of 5 would be my leftover. So 3 times the cubed root of 5 would be my answer there in simplified form. Okay, here's another one. The 5th root of x to the 17th. Well, and assume that x is not a negative, okay? In other words, I don't have to worry about the absolute value stuff here. So like all these other problems, we're looking for 2 items that multiply to give us the radicand. Okay, so what are 2 numbers that multiply together to be x to the 17th? Well, x to the 15th times x squared would give you x to the 17th. You're going to keep the base and add the powers. Now, this would be the best pair of numbers to use because I'm working with a 5th root, and I'd want that power to be a multiple of 5. Now, x to the 15th, that's the same as x cubed to the 5th. And I'm arranging this in such a way so that I've got the 5th root of something to the 5th power. That way I can get rid of the index and the power of 5, okay? And that's going to mean I'll be left with x cubed then. The 5th root of x squared would be my leftover from splitting this here earlier in the problem. Okay, so x cubed times the 5th root of x squared. You can't go any further with that. That's now in complete simplified form. We can maybe start problem 18 here. Problem 18 is just some more with simplifying. and assume that all variables represent non-negative numbers. So, from what you saw in this problem here, these problems, a lot of what we're going to be doing is arranging things into groups, okay? Arrange things into, the first group is going to be the things that you know the square root of or the cube root of, whatever the index is, and then the other group is going to be the leftover here, okay? Just like we were doing, in this problem 17. So simplify and assume that all the variables represent non-negative numbers, okay? Well, part A, I got the square root of 24x cubed. Okay, now if I look at 24, lots of things multiply by 24, right? 3 times 8, 2 times 12, 4 times 6. Okay, now I know the square root of 4, that's 2. So if I were to use 4 and 6, okay, once I split this radical into 2, 4 is going to go in the first one since I know the square root of 4 is 2. 6 is going to go in the second one since that's going to be my leftover, going to go in the second radical. X cubed is the same as x times x squared. The square root of x squared would be x. This extra x here is going to be in the leftover, and that'll go in my second radical. Okay? So I'm arranging things into, two groups, like I said. Things that I know the square root of, and then the leftover. So the square root of 4x squared, that'd be 2x. The square root of 6x, that'd be the leftover there. Okay, and that doesn't simplify further. Of course, make sure that you're simplifying as far as you can go, like I've mentioned that a few times now. 2x times the square root of 6x then would be my answer. Okay, here's another one. The square root of 45x squared y cubed. Let's go ahead and write our two radicals here. Things that we know the square root of and then the leftover. So with 45, okay, I know 9 times 5 is 45. And I know the square root of 9 is 3, so I'll put that 9 here. 5 would be the leftover. X squared, well, I know the square root of x squared is x, so that x squared term can go in the first radical. I don't have any leftover there from that. Y cubed, well, that's the same as y times y squared. And we know the square root of y squared would be y. Now I've got y times y squared, right? So that extra y, I'll put that in the second radical. That'd be the leftover there. So the square root of 9x squared y squared, that's 3xy. And then times the square root of 5y. The square root of 5y is my leftover, which doesn't simplify further. Okay. Why don't we stop the video right here?